Hello, my name is Matt Lewandowski. I'm a sales engineer with Enterprise DB. Enterprise DB is the leading worldwide provider of Postgres software and services that enable enterprises to reduce their reliance on costly proprietary database solutions and, in turn, significantly reduce their database expenditures. In this video, I'm going to show you how you can use the EDB Postgres Replication Server to offload Oracle reporting workloads to a Postgres database. At this point, you may be asking yourself why you would want to offload your reporting workloads from Oracle to Postgres. There are several reasons. Perhaps the most common reason is to reduce your Oracle licensing costs. By moving some or all of your reporting workloads to Postgres, you can free up your existing Oracle licenses for other more critical uses. Doing so can also help provide a safeguard against violating existing Oracle licensing constraints, which could result in unexpected additional cost. It's also possible that by moving your reporting workloads to Postgres, you can take advantage of free or lower cost options instead of investing in additional Oracle components or features. For example, if you want to extend your reporting capabilities to include geospatial information, you could use the freely available yet powerful PostgreSQL PostGIS extension as an alternative to using Oracle Spatial. Another reason why you might choose to offload some of your reporting workloads from Oracle is to facilitate the integration of data contained in Oracle with reporting workloads already being performed in Postgres that may or may not include information from other data sources as well. Yet another reason for choosing to move reporting workloads from Oracle to Postgres may be to support a phased approach of migrating your existing applications off of Oracle to Postgres altogether. Taking a phased approach, where possible, can ease the transition of migrating critical applications off of Oracle to the much lower cost EDB Postgres Advanced Server. Such an approach can help you reduce risk by allowing you to migrate the often simpler read-only applications first. One of the derivative benefits of this approach is that you can build up Postgres proficiency that can be applied on your remaining application migration efforts. A phased approach also provides increased schedule flexibility. In addition, offloading your reporting workloads as part of a phased application migration strategy provides the ability to deploy the Postgres-based read-only applications in parallel with your current Oracle applications, thus supporting a more graceful switchover of the applications after they have been sufficiently tested. Finally, moving your reporting workloads off of your Oracle server can possibly result in performance benefits. Doing so may allow you to more fully utilize the resources of your Oracle server and tune your Oracle OLTP system for optimal transaction performance. Similarly, having your reporting system on a dedicated Postgres server will allow it to be tuned for optimal query performance. Now that we have offered some reasons why you might choose to offload your reporting workloads from Oracle to Postgres, you may be wondering what EDB Postgres Replication Server is and how it can be used to perform this function. EDB Postgres Replication Server is a tool provided by Enterprise DB for near real-time replication of data from one database to another. The following are some of the highlights of the EDB Postgres Replication Server tool. The replication server provides the ability to perform both single master replication, or SMR, and multi-master replication, or MMR. Single master replication is used to produce and synchronize read-only replicas of information from a master database to one or more target databases. Multi-master replication is used to produce and synchronize replicas that support database writes in each of the replicas. Typically, an MMR system is deployed to promote the performance of localized reads and writes in a geographically dispersed database system. The EDB Replication Server supports Oracle to Postgres replication under a single master replication configuration. The EDB Replication Server provides the ability to filter the data available in a source table so that you can replicate only the data you need. Replication operations can be scheduled or performed continuously. In addition, synchronizations can be performed on an on-demand or manual basis if desired. EDB Postgres Replication Server, like all EDB tools, is included in any of the EDB subscription offerings and may be used on all the databases covered by the subscription. For those of you who are current EDB customers, EDB Postgres Replication Server is the new name for the tool formerly known as XDB Replication Server. Since the offloading of reporting workloads from Oracle to Postgres is supported under a single master replication configuration, the following graphic is provided to illustrate a high-level depiction of an SMR system. In a single master replication system, there will be a source database in which reads and writes are performed that will serve as the SMR master. Currently, the EDB Replication Server supports Oracle, SQL Server, Community PostgreSQL, and EDB Postgres Advanced Server databases being used as SMR masters. One or more subscription databases can be configured to receive replication updates from the master or publication database. The EDB Replication Server supports Community PostgreSQL and EDB Postgres Advanced Server databases being used as SMR subscription databases. After an SMR subscription has been configured and initialized, changes made to data in the corresponding publication are applied to the subscription databases either on a near real-time continuous basis, scheduled basis, or on-demand basis. If table filters have been assigned to tables in a subscription, only those changes that meet the filtering criteria will be applied in the subscription database. After replication has occurred, the subscription database will contain a replica of the publication data, making it available for read-only workloads. Now that we know a little about the EDB Postgres Replication Server, let's take a look at the various components that make up a typical Oracle to Postgres replication system. First of all, and quite obviously, there will be an Oracle database that will have one or more tables, possibly in more than one schema, that will be the publication database. There will also be a Postgres database, either a Community PostgreSQL database or an EDB Postgres Advanced Server database, which will serve as the subscription database and receive a read-only copy of the information from the publication tables. Next, there is the EDB Postgres Replication Server itself, which consists of both a publication server and a subscription server. The publication server is a program that configures the publication database for replication and performs replication. And the subscription server is a program that configures the subscription database for replication and initiates replication. Both the publication server and the subscription server run as services on the machine on which they are installed. Upon startup, they retrieve connection and authentication information for the publication database that has been designated as the controller database from the XDB replication configuration file. Either the XDB replication console or the XDB replication server command line interface can be used to configure, operate, and maintain replication systems. The XDB replication console is a graphical user interface, whereas the XDB replication server command line interface, or CLI, is a command line interface providing equivalent functionality as the graphical user interface. The CLI commands may be used in operating system scripts to automate replication system operations. The first step in setting up the Oracle to Postgres replication system is to create an Oracle publication database definition, which identifies the Oracle database connection parameters. When the publication database is added, the replication control schema is created in the publication database. The control schema is used to store configuration and operational metadata for the replication system. To identify which tables in the publication database are to be replicated, a publication is created. The publication can contain tables from one or more schemas in the database. With the publication information in place, a Postgres subscription database definition is added. Like the publication database definition, the subscription database definition identifies the parameters for connecting to the target Postgres database. Adding the subscription database definition results in metadata being recorded in the control schema about the subscription database. To complete the configuration of the replication system, a subscription is created. The subscription identifies the tables from the publication that are to be included in the replication, as well as any filters that should be applied to the publication tables. A replication schedule can also be specified for a subscription if desired. When a subscription is created, schemas and tables corresponding to those in the publication database are created in the subscription database. At this point, the tables in the subscription database are empty. To perform the initial population of the subscription tables, a snapshot replication operation is performed. Thereafter, changes will be propagated from the publication tables to the subscription tables via synchronization replication operations. All of the data in a subscription can be refreshed via a snapshot replication if desired. Now that we have a better understanding of the different parts of an Oracle to Postgres replication system, let's identify the steps that are followed to configure and perform the replication. The first step is to prepare the publication database for replication. This essentially requires creating or configuring an Oracle user with the necessary privileges for managing publication information and retrieving publication data. The publication user needs to be able to connect to the publication database, create control schema objects, read the publication, and create triggers on publication tables. The subscription database also needs to be prepared to support replication. To prepare a Postgres database for a subscription, create a new superuser or choose an existing superuser, like the Advanced Server Enterprise DB user, to be the subscription database user. Finally, create or choose the subscription database. With the database preparations in place, the remaining steps can be performed using the XDB Replication Console or the XDB Replication Server command line interface. First, add the Oracle database as an SMR publication database. Then create a publication with tables from the Oracle database. Next, add a PostgreSQL or EDB Postgres Advanced Server subscription database. Then, create a subscription under the subscription database, selecting tables from the previously defined Oracle database publication. Next, perform the initial population of the subscription tables with data from the publication tables by performing a snapshot replication. Finally, perform on-demand or scheduled synchronization replications to update the subscription tables with changes made in the publication tables. At this point, we're just about ready for a demonstration. Before jumping right into the demo, let me first set the stage by providing some information about the demo environment. For my demo, I'm using an Oracle Express Edition database with the HR sample schema running in a Docker container on my host machine. The SID of the Oracle Express Edition database is XE. This database will serve as my publication database. Note that since Oracle is running within the Docker container, the normal Oracle TNS listener port of 1521 has been mapped to port 49161. In most typical Oracle to Postgres replication systems, the port used for the Oracle database definition will be port 1521 instead. Also, for my demo, I have installed EDB Postgres Advanced Server 9.5 on a CentOS 7 virtual machine running on my host. In preparation for my demo, I have created an Aura Rep Demo database running on port 5450 within the virtual machine. I've also created a superuser named SubUser to serve as a subscription user. Finally, I have also installed the EDB Postgres Replication Server in the same CentOS 7 virtual machine where Postgres Advanced Server is installed. The publication server and the subscription server are both configured to use the default ports and user. For this demo, I'm going to use the XDB Replication console to configure and perform the Oracle to Postgres replication. So let's go ahead and launch it. On my Linux machine, I can launch the replication console using the shortcut in the Postgres Plus add-ons menu under the Applications menu. If I were running on Windows, I could similarly launch the application from the Start menu. After launching the replication console, if the publication server and the subscription server hadn't already been registered, I would have had to perform this step first. However, since I already registered the servers in the course of preparing for this demonstration, I don't need to do this now. When I registered the publication and subscription servers, I chose to save the login information. As a result, when the replication console was launched, it automatically logged into the servers, making them available for me to start working with. Since I have already prepared an Oracle database to serve as my publication database, and an EDB Advanced Server database as my subscription database, the first step I need to take is to add a database definition for the Oracle database under the publication server. To do so, I will expand the publication server. If I expand the SMR node, the list of any publication databases I may have previously added will be displayed. To add the Oracle database, I will select the SMR node, bring up the context menu, and then select Add Database. In the Add Database window, I will first select Oracle from the Database Type dropdown. Then I will enter the information that will be used to connect to the Oracle database. As I mentioned earlier, normally 1521 would be entered for the port. However, since I'm connecting to an Oracle XE instance running in a Docker container, port 1521 has actually been mapped to port 49161. That's why I'm using that here. Now that I've entered the connection parameters, let me select the Test button to verify that I can connect to the database. The connection parameters are good. I will select OK to close the message dialog, and then the Save button to save the database definition. As you can see, there is now an Oracle database under the SMR node. Now I need to create a publication. To do so, I will select the Oracle database, open the context menu, and select the Create Publication menu option. In the Create Publication window, you can see the list of tables in the Oracle database that are available to be included in the publication. First, I will give the publication a name. Since I want all of the tables that are shown, I will check the Select All checkbox. If I wanted to define any filters on the tables, I could select the Table Filters tab. However, since I plan to replicate all of the data, I'm not going to worry about creating any filters at this time. Also, since I plan to perform synchronization replications, I will leave the snapshot-only replication option unchecked. Now that I've gotten everything specified the way I want, I select the Create button to save the publication information. If the publication is created successfully, a message box will be displayed. Select the OK button to close the message box and the Create Publication window. Now we see the publication we just created under the Oracle database, as well as the tables that make up the publication. Let's now set up our subscription. First, expand the subscription server node to see the list of any previously defined subscription databases. Since we don't see our subscription database in the list, we need to add it. Select the Add Database option from the Subscription Server context menu. Since we are going to use an EDB Postgres Advanced Server database for our subscription database, we don't need to change the database type option. We simply need to enter our database connection information. The database we will be using for the subscription is on the local machine and running on port 5450. Our subscription user is the sub-user, and our database name is Aura Rep Demo. To make sure our connection information is good, we'll select the Test button. Select the OK button to close the success message, and then the Save button to save the subscription database information. Since we specified localhost for the database host, a warning message is displayed. In a production environment, we would want to follow the advice in the warning message. However, since this is only a demo, we can select Yes to ignore the warning and to continue. The database has been added to the subscription server. Now we need to create a subscription. We can do this by selecting the newly added database and selecting the Create Subscription option from the context menu. In the Create Subscription window, we'll specify a name for the subscription and enter the appropriate host, port, username, and password information for the publication server. Keep in mind, these parameters are for the EDB Replication Server publication server, not the publication database. In my environment, the publication server is running on the local machine on the default port of 9051. The default admin user is also being used. After entering the information, select the Load button to load the list of available publications in the Publication Name dropdown. For this demo, we're going to select Oracle HR Publication. Then we'll hit the Create button to create the subscription. Again, since we specified localhost for the publication server host, a warning message will be displayed. As before, we will select the Yes button to ignore the warning and continue creating the subscription. A message box is displayed indicating that the subscription has been created. Click the OK button. Now we see the Oracle HR subscription under our subscription database. If we expand the Oracle HR Publication node under the subscription, we will see the tables that make up the subscription. At this point, if we were to look in the Aura Rep Demo database, we would see that the HR schema and tables from the publication have been created. However, no data has been transferred to these tables yet. To perform the initial population of the tables, we need to perform a snapshot by selecting the subscription and then the snapshot option from the context menu. A snapshot dialog is opened. If desired, we can check the verbose output option to display logging information as the snapshot is performed. Selecting the snapshot performs the data snapshot. The message box indicates that the snapshot was successful. Hit the OK button to close the message box and then the Close button to return back to the Replication console window. Now is a good time to take a look at our subscription database and inspect some of the tables. I installed the EDB Postgres Enterprise Manager, or PEM, tool in my environment, so I'll use it to do some inspecting. I'll open the PEM tool using the shortcut under the CentOS Desktop Applications menu. Our subscription database is running on port 5450 on the local machine as the prod database cluster. I'll double-click the server to connect to it and enter a password if prompted. To inspect the tables replicated to our subscription database, we'll expand the Tables node for the HR schema under the Aura Rep Demo database. Let's start by looking at the Regions table. If we expand the Columns node under the Regions table, we'll see that there is a Region ID column and a Region Name column. To look at the data, I'll choose the View All Rows option from the Regions table context menu. The Regions table has 4 rows in it. Now let's look at the countries table. The countries table has 3 columns and 25 rows. Finally, let's look at the locations table. The locations table has 6 columns. It also currently has 23 rows, 4 of which correspond to US locations. To test a synchronization replication, let's open an Oracle SQL Developer window and enter some data in the Oracle publication tables. First, I'll minimize the PEM window and switch views to the machine where Oracle and SQL Developer are installed. I have already opened a SQL Developer connection to my Oracle database as the HR user. I'll start by inserting a new record in the regions table. Let's add a row with a region ID of 5 and a region name of Other. Next, I'll perform a commit. Then, let's add a row to the countries table with a reference to the new region record. I'll create a country record with a country ID of AT, country name of Atlantis, and a region ID of 5. Commit the new row. Finally, let's update a locations table record and also delete a record from that table. Now that I've updated the one row and chosen to delete another, I'll perform a commit. Now let's switch back to our machine with the XDB Replication console. To replicate the changes that were just made in the Oracle publication database, I'll select the Oracle HR subscription and select Synchronize from the context menu. In the Synchronize window, I'll select the Synchronize button. The synchronization operation appears to have been successful. Let's take a look in the database to be sure. First, I'll look at the data in the regions table. As you can see, our new region record has been added to the table. Next, let's look at the countries table. As expected, the new countries table record has been added to the database. Finally, let's look at the locations table. The locations record that was updated in the publication database has been updated, and the record that was deleted is no longer present in the subscription database. The XDB Replication console also provides views for reviewing synchronization history. If I select the Oracle HR Publication node under the Oracle HR Subscription node, and then select the Replication History tab in the right-hand pane, a summary history of replication operations performed for the publication is displayed. In this view, we can see a listing of the replications that have been performed and the number of transactions processed during each operation. It is also possible to view the replication history for each individual table in the publication. Selecting the HR Regions table and then the Replication History tab shows the initial snapshot that contained 4 transactions to populate the table and a synchronize operation with 1 transaction. Selecting the View Data link opens a window that displays information about the specific transactions that were processed. As expected, the History Details window shows that one insert was processed for the table. Likewise, we can look at the HR Countries table replication history. Again, selecting the View Data link shows the individual transactions that were processed. Finally, if we view the details of the most recent replication on the HR Locations table, we see that one update and one delete were processed. Up until now, we've only performed on-demand replications. However, it is possible to have changes in the publication be automatically replicated for a subscription. To configure the system to perform automatic replication operations, select the subscription, and then the Configure Schedule context menu option. This opens a wizard for configuring the desired schedule. For example, to have synchronization replications performed on a continuous basis, select the Synchronize and Continuously Radio buttons. Selecting the Next button loads a wizard screen corresponding to the previously selected options. By default, continuous replications are performed every 10 seconds. For our demo, we'll go with the default setting and select the Next button. Selecting the Finish button saves the schedule configuration. We can verify the replication schedule we configured by selecting the subscription database and then selecting the subscription. The General tab now shows the scheduled time, previous fire time, and next fire time. If I select the publication, the Real-Time Monitor tab shows the date and time, status, number of rows updated, and duration of the last replication. The values of these fields are updated in real time after each replication operation. If I select the Replication History tab and uncheck the option at the bottom of the pane to show history with transactions count greater than 0, the history of all replication runs will be displayed, even if no transactions were processed. Checking this option results in the history only showing those replications that process transactions. That brings us to the end of our demo. During this demo, we focused on the typical steps involved in configuring a single master replication system to support the replication of data from Oracle to Postgres. While there are many aspects of the EDB Postgres replication server left to explore, hopefully this demo has resulted in a better understanding of the main features of this powerful tool. Thank you for viewing this video. I hope that you found it informative. To learn more about the EDB Postgres replication server, or for more information about Enterprise DB, our products and services, or to download installers of our Postgres database products and tools, visit our website at www.enterprisedb.com. Thanks again.